Greetings and good morning on another sunny morning. The second sunny morning in a row, a sure sign of turbulent times ahead. Anyway, in this episode, we want to look at a method of calculating pi. Now, of course, there are several lines of attack for this. This particular one is attributed to none other than Sir Isaac Newton around the year 1700 AD. And we start off by noting that when you differentiate inverse sine of x, you get 1 minus x squared to the power minus a half. For those who are not familiar with that, I've inserted that in the footnote in red paint. Now, expanding this by the binomial theorem, we get 1 minus x squared to the power minus a half equals 1 plus a half times minus x squared plus minus a half times minus 3 upon 2 times minus x squared all squared over factorial 2, and so on and so on and so on. I think you'll be able to follow what's been done there. And then the long and the short of that is that comes down to 1 plus x squared over 2 plus 3x to the 4th upon 8 plus 5/16 x to the 6th plus 35 over 128 x to the power 8 plus etc., etc., etc. And I'm just using the first four terms. Now, that last series is a series which represents inverse sine of x. So by integration, we'll get back to inverse sine of x, and integrating term by term, that'll give us x plus x cubed over 6 plus 3x to the 5th over 40 plus 5x to the 7th over 112 and 35x to the 9th over 1152, etc., etc. Now, we're going to let x equals 1/2. Now, sine inverse 1/2 is 30 degrees, or pi upon 6 radians. We have to use radians, of course. So pi upon 6 equals sine inverse 1/2, and then inserting 1/2 in place of x, we'll get 1/2 plus 1 over 48 plus 3 over 40 times 32, and so on and so on. I think you will be able to fill in those gaps quite easily. And from these, just using these first terms up to x to the 4th, we will get the value of pi to be 3.1415 and then 11172 on a calculator, and that is accurate to 5 significant figures. Thanks very much for listening, but I'll just explain the how we did the differential of inverse sine of x. So start off by letting d theta, integral of d theta is theta obviously, and just use the substitution x equals sine theta, and therefore dx is cos theta d theta, which will be square root of 1 minus x squared d theta, and then the result from that should be fairly obvious and straightforward. And thank you again for listening. Goodbye.